Syzygy, Episode 8, Frozen Dunes of Pluto. And welcome back to another episode of Syzygy. This is episode number 8. In this episode, we're going to be talking about what used to be planet number 9, and then it kind of got a bit demoted. When I was growing up, we always had 9 planets, and Pluto was the last of them. But poor old Pluto, it's not a planet anymore. So we'll be talking about that, and in particular, some really interesting news that's come from Pluto really, really recently. The fact that it's not quite a simple little lump of rock that we thought it was. It's pretty complicated. Joining me, as ever, on the microphone is Dr Emily Brunsden. Hi, Emily.
Hello, hello.
So, Pluto, what's been going on? What have we just learnt about this far-flung sphere of rock orbiting the sun?
Well, it's really exciting. Far from being this kind of cold, dead lump of ice that's just drifting out there in the far reaches of space.
Which is what you'd sort of expect, right? I mean, it's really far away. It's a long way out, and it's not even, I mean, we'll get to this in a minute, but it's not even big enough to be proper planet. It's sort of, demoted. So we always just kind of assumed it was kind of dull, but it's not.
No, it's very exciting, in fact. And we've got evidence now that we've got dynamic processes going on the surface of Pluto.
Now, dynamic processes, that's a fancy way of saying there's stuff happening down there on the surface.
Yeah, real-time things are happening.
Yeah.
And we can see that because we can see these dunes of methane which are formed on the surface of Pluto.
Which is really cool, because not only does that mean, like, to get dunes, not only do you need to have methane on the surface able to be pushed around, but you've got to have an atmosphere and winds. I mean, dunes come from, on Earth, sand dunes come from sand being pushed around by the wind. So Pluto's got wind, which is cool.
Stuff moving around on its surface.
Yeah, who knew? Okay, so we're going to be talking about that today. But before we get there, I think there is a really large, rocky elephant in the room, sort of a planet-sized or maybe slightly smaller than planet-sized elephant in the room, which is Pluto's status. And frankly, I'm amazed it's taken us 8 episodes to get here, because amongst a certain number of people who do follow, astronomical things, the demotion of Pluto from planet to dwarf planet was a big deal. And there are a lot of people who are still really quite bent out of shape about this. So let's back up and talk about Pluto, the history of the planet, and we'll work our way up to that particular elephant. Emily, when did we first learn that Pluto was there?
Well, we found Neptune because we knew that from orbital mechanics there was another planet that had to be out there in the solar system. And then after finding Neptune and starting to observe it for a while, this is in the late 1800s, Neptune was doing something a little bit weird. It was wobbling around a little bit in a way that it shouldn't have.
When you say wobbling around, it's not like people spotted it and you could see it wobbling around in real time. Neptune's orbiting it takes a really long time to go around the sun. If you observe its orbit for long enough, then you can tell that orbit's not what you'd expect from what we can see.
Something was disturbing Neptune.
So there had to be something else out there.
Yes.
And that something
it was eventually found to be Pluto, but it took us a long time to find it. It was a real planet hunt, if you like.
So how long?
So we started looking for it in the early 1900s. Very famously, Percival Lowell started, he founded his own observatory and started hunting for this planet. Really, really, I guess, frustratingly in some ways, he actually kind of did find it, but he didn't see it for what it was at the time.
So what do you mean by that? What did he see?
So they made some mathematical predictions about where it should be in the sky, and they were photographing those parts of the sky. And it was actually found when they went back into those photographs that it was there at the time.
Oh, right.
This
so
is in
just missed it.
Yeah, 1915. Unfortunately, Percival died in 1916. So he didn't actually see the discovery of his Planet X, he was calling it. But they employed another astronomer a little bit later on. And in 1930, he managed to find it. This is a guy by the name of Tombaugh.
Right.
And that's
several decades it's taken to find this.
Yeah, it was a tricky thing to nail down, right? And it's so tricky because it is so small and so far away from the sun.
Yeah, I mean, it's tiny, isn't it?
It's really tiny.
You know, it's smaller than Mercury.
It's
Mercury,
smaller than the moon.
Yeah.
So you're looking at something that's about the volume of the moon.
Right. And the moon is already considerably smaller than the Earth. So we're talking quite a small lump of stuff.
Yeah.
So it's quite staggering they found it at all, given how far away it is.
Exactly, yeah. And it was only because of this relationship that it had with Neptune that it was able to be found. In fact, it has this, what we call resonance with its orbit. So every time that Neptune goes around twice, Pluto goes around 3 times.
Right. And so that particular orbital resonance, that sort of locking of the two planets, is a telltale sign. When you're looking at Neptune, you're looking at one of those pairs, it's pretty clear there's something else there. That's what they saw in the wobble that you talked about.
And Pluto even comes inside of Neptune's orbit at some points.
Yeah, it is. It's got a really weird orbit, isn't it?
Yeah,
It comes inside Neptune sometimes, and it's tilted quite a lot, isn't it?
Yes, yeah. So it's not in this nice disk, which all the other planets are in. And this you could kind of think of might be a reason why it wouldn't be called a planet if it's got this weird orbit that's an ellipse instead of a circle, if it's not behaving like the other planets.
It's already looking a little bit dodgy, let's face it.
Yeah, but those aren't actually anything to do with why Pluto is not a planet.
Well, we'll get there in a second, but I'm actually curious. So where did the name come from? Why Pluto?
Well, they just early 1930s, they had an idea of what they might want to call this thing.
Planet X, sounding very science fiction-y, but I mean, that's not going to last, really, is it?
Yeah, well, and we have a kind of a convention that we want to sort of stick to in terms of our planets. We've named them mostly after gods, so kind of makes sense. We should name something else that we found after another god. And in fact, this the name Pluto was suggested by an 11-year-old girl in Oxford. Percival Lovell was, and the observatory were in the US. And she suggested Pluto, which happened to have 2 really nice components to it. So Pluto is the god of the underworld. So
right.
It's all kind of very dark and mysterious and maybe cold as well. But Pluto, PL, also makes Percival Lovell's initials.
Oh, I hadn't even thought of that.
Which was really, really nice. Yeah.
Nice one.
So the astronomical symbol to this day is a P, capital P, and then you make the bottom of the P into an L. So it's 2 letters put together.
Do you know, I've actually seen that before and I had never noticed that. Well done, Chris. Nice work. So hang on, so Lovell was in America. How did an 11-year-old girl in Oxford end up naming it? What's the story there?
It was a story with her father was a scientist and a philosopher and involved with another person. So it's kind of he knew someone else who knew someone else who knew someone else.
Right. And someone went, hey, that's a really good idea.
Yeah.
Pass that one on.
So it's kind of almost like the modern day systems where you might have name a star or name a such and such a thing competition.
All right. So it was discovered in the 30s. And then quite a few years later, something happened. A bunch of astronomers got together and made a decision. Tell us about that.
Yeah, well, in the 1990s, we started to get a lot better at discovering things in the outer edges of our solar system. And we found quite a few things that were kind of similar and in some cases bigger than Pluto.
Mm-hmm. Okay, so that's fine. More planets, that's okay.
So we could sort of start just tacking them on, have 10 planets, 11 planets, 12 planets. But there was a little bit of a concern as to where was this going to end? How many often do we want to rewrite our children's books?
Exactly. And I mean, it's hard enough to remember 9. You know, if we're getting up into the several dozen, that's getting a bit ridiculous. But there's more to it than that, isn't there? There's more to it than just, well, we don't want to have too many planets because we like small numbers.
Well, no, but we never had a formal definition of what is a planet.
Ah, yeah. See, therein lies a bit of a problem. Because if you haven't got a formal definition, or at least a consistent one, then anything else that comes along is it not? Well, at some point, you've got to draw a line. So how did that get resolved?
Well, I remember also that the 1990s was this period where we were discovering planets for the first time in other solar systems.
So added pressure to say...
We really need this good definition.
Yeah, what are these things? What are we calling them and why?
So the International Astronomical Union in 2006 came up with 3 criteria which you're going to have to hit if you want to be a planet, at least in our solar system. So you can go through each of the 3. They're pretty straightforward.
Yep, number 1.
So number 1 is you have to orbit the sun.
Fair enough. Yeah, I think no one, that's pretty uncontroversial.
Yeah.
I think no one would argue with that.
Yeah, so even though we have like moons of Jupiter and Saturn and so on, which are really big and kind of look like planets in their own right, they don't go around the sun, they go around another planet. So they're moons.
Okay.
So going around the sun. And of course, Pluto goes around the sun.
Big tick.
Big tick,
Big tick for Pluto. Yep.
Yeah. The next thing is kind of like a size limitation. And the way that that's defined is rather than saying you must be this big to be a planet, then because different planets can be made of different things.
Sure.
We wanted to have a definition that was a bit more all-encompassing and
Yeah,
inclusive.
I mean, you've got the rocky planets, Mercury, Venus, Earth, Mars, Pluto, and you've got gaseous planets, which are really big. You've got your Jupiter and your Saturn and your Uranus, and Neptune is a gassy planet as well. And yeah, so in order to have something which, okay, let's not worry about exactly what you're made out of. What's the definition in terms of size?
So the technical term is there's enough hydrostatic equilibrium.
Okay, that is technical. So breaking that one down.
And basically, are you big enough to become a sphere?
Oh, okay, right.
Yeah.
Right. And so there's a distinction there because, not so far away, we've got the asteroid belt, which has got some fairly large chunks of rock in it.
Yeah.
But they're not big enough to form spherical planety things.
No,
They're
they
just
look a
lumps
bit
of
like
rock.
potatoes,
Yeah,
really.
yeah. So potato, no. Sphere, yes.
Yes, yeah.
Good, okay.
So you've got to have enough gravity for that to happen, to become a nice sphere.
Yeah, and again, tick for Pluto, right?
Indeed,
Because Pluto is round.
Yes, it is. Yeah, yeah.
All right, so 2 for 2.
Yep. And
So
now,
it all hinges on number 3.
here's the crunch. You must have cleared your neighborhood of other material.
Right, and cleared your neighborhood. So what does that mean?
So in your orbit, as you go around, there can't be lots of other bits, either lots of small bits or even some other big bits that you're kind of competing with in your orbit.
So you've got to be the dominant thing in your orbit,
Yep.
or at least, clearing it out. If you're the biggest thing going around over long periods of time, everything else is either going to be bashed into or swung out of the way by gravity. So in number 3 then, I'm guessing Pluto fell over at that last hurdle.
Yeah, and we can actually put some numbers on this, which can be quite illuminating. So you take the Earth. The Earth is 1.7 million times more massive than everything else in its orbit.
Okay, so that's significant. So if you're talking about Earth dominating its orbit, 1.7 million times bigger. Okay, I'd call that dominant.
Yeah.
Fair enough.
Definitely
Well done,
dominant.
Earth.
Yep.
Pluto?
is 0.07 times the mass of everything else in its orbit.
Ah,
So it's actually smaller than the mass of everything else that's
right.
there.
That's a bit embarrassing if you're Pluto.
Yeah.
Now, that doesn't mean that there are other things which individually are larger than Pluto in its orbit. That's not what you're saying.
No, although there's things that are not too far away
Right.
that are.
But you're saying if you add everything else up around, in its neighborhood, all of that stuff is actually, outweighs Pluto. It can outvote it and say, no, you're not a planet.
Yeah, exactly.
Rats.
Even one of Pluto's own moons, Charon, it's quite significantly close to being the size of Pluto. It's a bit smaller, but it's so big compared to Pluto itself that the center of mass, which is the point that both objects go around, is not inside Pluto itself.
Yeah. Okay, that is a bit embarrassing.
Yeah.
The moon goes around the Earth, but their center of mass, their center of rotation is inside the Earth. And so you can legitimately claim that the moon is going around the Earth and not the other way around. You're saying Pluto and Charon,
Yes.
one of its moons, that's not the case. They're going around each other. They're
Yeah.
going around a common point that's outside of Pluto.
It's almost a binary system. Yeah.
So that is a bit embarrassing. And I can kind of see how Pluto's falling on the wrong side of the law on this one.
So we can also, of course, turn this around, and actually Pluto in some ways got promoted because it got changed from being probably the least important planet in its category to being definitely the most important dwarf planet.
Yeah, I'm guessing that the Pluto fans found that as a bit of a, that's really not going to satisfy them.
But if you're a dwarf planet specialist and you've suddenly got this amazing new planet in your classification, that'd be quite exciting.
So there are like a half a dozen people going, yay, we got Pluto, and everyone else is going, it's not fair. Consolation prize for the Pluto fans. Okay, all right. But it did. I mean, it created this massive amount of concern from Pluto fans, which for those of us who are outside astronomy, I can kind of see it because I grew up with Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto's number 9, and it's, those are the planets. And so to have one of them taken away is a bit odd. On the other hand, I can get it. Things change. Why was there, and still is to this day, such consternation over Pluto's status? Why is it so controversial? Is it just people don't like change?
Well, but there's a few things. I think emotional responses can be a bit overweighed in some situations. That's not to say they're not important. Actually, having an emotional response to science is a good thing, I think.
It's not a bad thing.
You care about it. And we needed to make this definition, and perhaps it wasn't the best definition. Some planetary scientists still disagree, actually, with this classification scheme. But probably what we've ended up doing is stumbling upon a really good set of criteria, although maybe the method we got there wasn't actually quite
how do you mean?
Quite as straightforward. Well, maybe we sort of accidentally got to the right answer rather than through a systematic process of investigation.
So are you suggesting that maybe a few people who are frustrated about this decision got their noses a bit bent out of shape by the way that this was done? That perhaps, maybe people felt a bit railroaded, or they weren't given enough input, or something along those lines.
Yeah.
So politics, basically.
A little bit, yeah.
Yay.
Yeah. But, the Kuiper Belt, which is this area of the outer solar system, it sort of runs from about 30 times the distance that Earth is from the sun. So 30 times as far away as we are to 50 times. It's pretty far away. This is actually a really interesting place. And in some ways, this whole demotion of Pluto shone a bit of a light on this really interesting part of our solar system that has really interesting bits in it. I mean, Eris, for example, was one of these planets, well, maybe it's a dwarf planet, that's actually bigger than Pluto by mass out there in this Kuiper Belt.
And we're talking well out beyond Pluto's orbit.
Not too far from Pluto.
Right, yeah.
Yeah, and or lots of other objects which are at similar resonances with Neptune as Pluto is. There's heaps of stuff out there. There's more than 1,000 things in this Kuiper Belt that we've found so far. So, we know a lot more perhaps about our outer solar system than we ever did before. Well, definitely than we ever did before.
So maybe the focus on Pluto and the controversy around this decision kind of helped extend our view out from, the inner 9 or 8 as it is now, to say, well, the solar system's much more interesting than just that. So let's put the whole Pluto thing down for a second, and let's go and have a look at all this stuff out here. It's really, really cool.
Yeah, and it's still really important to the inner solar system where we live. We think that most comets come from this area of our solar system. Possibly it's a reservoir for water, organic molecules, all sorts of things sort of buried out there in the deep, dark depths of our solar system. All
right. Well, I guess Pluto fans can take a little bit of heart from that, all right, not a planet, but the coolest and most interesting of the dwarf planets. Let's go with that. King of the dwarfs. We'll do that.
And it was still important enough to send a space probe out to.
Yeah. So which probe was that?
This is New Horizons.
Mm-hmm.
New Horizons was launched in 2006. Did a little bit of a Jupiter flyby, but took nearly 10 years to get out to Pluto.
Well, it's a long way.
It's a very long way.
I mean, even getting to Jupiter is impressive, but we're talking a lot further than that.
Yeah.
So
it's a long time when you're an astronomer waiting for these results to come.
But when it got out there, it actually found that Pluto was a very interesting place.
Oh, we saw these gorgeous photographs as New Horizon approached Pluto. So this was July 2015, a couple of years ago. But I remember when those images came out.
Yeah.
You saw this little icy lump in a completely, to excuse the pun, a new light.
Yeah. I mean, the best images we had before that, I don't know whether they were from Hubble or what telescope, but they were literally these pixelated, you got maybe 20 pixels along the side. And they were these grey, lumpy, pixelated images. And now we've got these incredibly detailed, actual photographic quality images of this amazing planet. Or dwarf planet, sorry. Yeah, it's such a revelation overnight.
We can see colours, we can see surface features. You probably remember the big release about the heart on Pluto.
Yes, although the one I liked was in taking that same... So that's a surface feature which looked like a love heart, which was kind of, we love you, Pluto. Oh, that's sweet. But the one I quite liked is someone who photoshopped the Disney character Pluto on top of that. And it's almost a perfect fit. It's really, really good. So that's kind of nice. So, yeah, we got this amazingly detailed picture of this incredibly distant, cold, icy world. But it also meant that we could have a really good look at what actually is on Pluto, what it's made up of, and what's down there. And that kind of leads us to this new paper, which has just come out, which is talking about some of the surface features and what that tells us about the environment on this tiny little spherical lump of rock way out on the distant edges of the solar system. So what do we know? What have we found out about Pluto?
Well, the key thing we were trying to do with New Horizons is take pictures, and we took an awful lot of pictures of Pluto. And we were looking at, in this paper that's looking at a plane called the Sputnik Planitia. So it's a plane. It's actually in the heart, if you can imagine the heart shape on the surface of Pluto, right, which is near the equator of Pluto.
We'll put some pictures in the show notes. We'll show you where it is.
It's up in the left lobe, if you like.
Right,
of the
okay.
hub. And it looks like you've got some mountains on the side of it. Now, these are icy mountains. They're huge mountains going up to 5 kilometers in height.
Wow.
So, they're not insignificant features themselves. And then next to that, we've got this sort of big desert plain, ice desert, right? There's not sand or rock on the surface. It's all ice.
Now, when you say ice, is it ice, or are you saying ice as in frozen stuff?
Frozen stuff, really.
Stuff.
Yeah,
so not ice water.
No. So what we're talking about, temperatures of minus 230 degrees.
Cold.
Really cold.
Seriously cold.
So things that are gases on...
One of those temperatures where it doesn't really matter whether you're talking about Celsius, Fahrenheit. It's just cold.
It's really cold. But so the gases and so on that we see on our planet in sort of normal temperatures become ice at that temperature. One of the important ones is nitrogen on Pluto, and also methane. And it's methane that we think are forming these dunes on the surface of these plains.
Right, these dunes which have been seen in this latest paper and in the flyby by the mission. And dunes in the same sense that we see dunes here on Earth. We see sand dunes created by wind blowing tiny particles across the surface, and the way that the flowing air on Earth, the flowing atmosphere, interacts with these mounds of tiny particles means that they build up and then drops off on the other side, and you have these hills and troughs, often in very regular patterns. And when you look at the surface of Pluto, hang on, those are dunes.
Yeah.
Those are actual dunes. Yeah. And so you work backwards and think, something's making them.
And we even see snow dunes on Earth as well, actually, in Antarctica. So we're sort of familiar with even these exotic icy processes that are going on. So you think, okay, there's dunes. That's nice. What can we actually learn from this about Pluto? Well, a few things. First of all, we can say that because there's dunes and not craters on the surface, that tells us something about the age and the timescales of the processes that are happening.
Right. So presumably it means that these things are forming and changing and reforming over quite short time frames.
Yeah. So we've mentioned that things in our solar system that are old, that don't change, have lots of craters on them. So the moon or Mercury. But things that have any kind of geological processes, like the Earth has volcanoes and oceans and blah, blah, blah. We talked about the icy plumes on Europa, which also have similar changes to the surface of Europa. And then there's no craters in this sort of area of Pluto either. So we can assume that there's something that's changing the surface, that's removing the craters of objects after they've hit.
Removing them, wearing them down, filling them in, covering them over.
Yeah.
Yeah.
So that tells us initially that the surface of Pluto, at least in this location, is only something like 500,000 years old, at least. So, that's cool in itself. It's really not a dead planet or dead dwarf planet.
It's not. It's not a cold lump of rock in the sense that the moon is. It's a dynamic thing.
And then if we go down into what could be possibly creating those dunes, you need 3 things to happen to create a sand dune. This is really interesting.
Yeah.
I learned a lot about sand or dunes in general from reading this article. You need 3 things to happen. You need to have an atmosphere that's going to be dense enough to create your wind, which it wasn't actually obvious that Pluto would have that.
No. I mean, if you had asked me yesterday, before I read this paper, because I do my homework, if you'd said to me, does Pluto have an atmosphere? As a non-Pluto expert and non-astronomer, I would have said, don't be stupid. The moon doesn't have much of an atmosphere.
Not much, no.
I mean, tiny little bit.
Tiny, yeah.
So I would have thought, you got Buckley's chance. There's no way that Pluto's got an atmosphere, and yet apparently it does.
Yeah, it's got an atmosphere.
Not much of an atmosphere.
Not much.
But enough.
But it's enough, and it's dense enough. And it's dense enough because you have to have wind. Mm-hmm. And you have to have stuff blowing around to have wind.
Yeah, so it's not this incredibly fine, vapor-like atmosphere that just isn't doing anything. It's enough to actually blow around.
Yeah. It's not this extreme winds that you get on some of the really, like Venus and Jupiter. It's not these big blasting winds. In fact, the wind speed they've calculated from these dunes is actually really modest.
It's about the same as on Earth.
Yeah,
I read.
10 meters per second, which is 36 kilometers per hour. I frequently see that as a number when I'm observing.
But if you were standing on the surface of Pluto, you might not actually feel that because the atmosphere is, was I reading, 100,000 times less dense than on Earth.
Yeah.
So it may be moving around at the same speeds, but there's a heck of a lot less of it.
Yeah, exactly. And that's why it's sort of possible to go at a higher speed as well.
Sure. But it is there, and it's enough to move around the tiny particles which are on the surface. And those tiny particles are what? I mean, it's not sand.
Yeah, so that comes to our second condition.
Okay.
You need these particles, so you need it to be dry. Because if it's kind of wet, or at least not wet in the sense of water, but wet enough that the particles are going to start to melt a little bit and stick together.
And form bigger lumps.
Yeah. Then you're not going to be able to lift them off the surface and push them around. Right,
so they've got to be small and they've got to be dry.
Yeah. That's not actually so surprising that a lot of these very, very cold places are very dry. Think about Antarctica on our planet. It's an incredibly dry place.
It's technically a desert.
Yeah.
Which is weird, but true.
Yeah. So Pluto's not really, that doesn't surprise us. We thought that might actually be the case.
Cool.
Yeah. And we also got to get these particles up off the ground.
Right. This is number 3.
Yeah. This is a little bit trickier. So you can't just have the wind sort of push, because the particles will stick to one another just through kind of like a similar process to surface tension. They're kind of just attracted to each other. And the wind might not be quite strong enough to just blow them around willy-nilly. So we need to get these particles up off the surface. And that's probably done through sublimation.
Okay. Again, another technical word. So sublimation, what are we talking about?
So this is the process where you have a solid that goes to a gas basically instantaneously without sort of bypassing that middle phase, which is going to a liquid.
Right. So normally a solid would melt and turn into a liquid, and then the liquid would boil and turn into a gas. But sublimation is skipping out that step in the middle and just going, I'm a solid, no, I'm a gas. I'm a gas, no, I'm a solid. And just jumping directly between them, which you can do under certain conditions with certain types of materials.
Yep.
It depends on the temperature and the pressure and the type of material, but it's possible.
Mm-hmm. And you can do it on Pluto when you have the sun, because although being incredibly far away, the sun is still in the sky in Pluto. It's still bright, and it still has a temperature impact, especially as Pluto rotates around. So when that sort of part of Pluto comes into the sunlight, you might get a bit of sublimation of these methane ices coming up and then reforming, and the wind's sort of blowing them around in the meantime.
So the sublimation, the turning of the solid into the gas, is enough to blow some of these tiny grains up off the ground. Yeah,
it gives them a sort of enough energy to be pushed around.
And then these incredibly thin but modestly moving winds can blow them around.
Yeah.
And so you can then have the processes to form the dunes.
Yeah, so these winds are probably coming down off these icy mountains and pushing the dunes, and they're all sort of lined up in a way that you'd expect from those. And the sizes of the dunes can actually tell you a little bit about what the grains, if you like, of these dunes are made of. I think sort of weirdly, coincidentally in some ways, they are a similar grain size to sand on Earth.
You go all the way to the other end of the solar system and find stuff that looks awkwardly similar to what we find here.
Yeah.
I mean, that's really cool.
Yeah. So there's some beautiful pictures of some dunes in China in the science paper that that they published the research in that are very, very similar to the structures that you can see on Pluto.
Okay, so we've got this amazing new picture just in the last couple of years. You know, it took us 10 years to get out there, but it was worth it because we've just got so much data about this tiny little lump on the distant, far-flung reaches of the solar system. So is that it? Are we done with Pluto now?
I don't think so.
No
way.
Goodness me, no. So what's next?
Well, so of course we've still got lots of data from New Horizons to analyse. We only got it a couple of years ago, and you can pore over every image and find every available piece of information in there. So we're going to see more just from the New Horizons missions. Now, the problem is after that, we don't actually have any missions planned to Pluto. I mean, fingers crossed that the results from the New Horizons probe are really going to spur our scientific interest. I think they already have. So we're looking at proposals for the next, what they call decadal survey by NASA. This is when NASA chooses all the missions it's going to do in the next 10 years.
Right.
I'd be very surprised if there isn't a Pluto mission that goes as part of that. Maybe not just to Pluto, because you kind of got to get as much bang for your buck as you can.
And if you're going to go all that way, you're going to be passing, ideally, a few other places along the way, particularly if you need a little bit of a slingshot up to get out to Pluto a little bit faster and go around some of the other planets. So, yeah, it would be a part of a broader mission.
Yeah, so we'll have some lots. New Horizons itself is actually carrying on. It's, I think, the 5th object that we have sent that has left our solar system, for some definition that you might have of solar system. But anyway, it's heading off to a Kuiper object. Now, this one has not got such a nice name as Pluto.
Right.
It's called 2014 MU69.
Yep.
Yep.
But, I mean, I guess if you've found all of these things out there in the belt that, you know, you can't name all of them. That's starting to get crazy, so you just got to go with the catalogue name. Fine.
I'm sure we'll think of something nice before it gets there, but it's going to be there on New Year's Day 2019.
Oh, cool. That's not far away at all.
No, so we're going to get to see some new pictures of another Kuiper Belt object, another potentially dwarf planet.
Will that be the first time we've done that?
I think so.
Because
we might have something from Voyager, but... Yeah.
We should look that up.
Yeah.
We'll get back to you on that one. But yeah, that's going to be cool. And that's only like 7 months away, 6 months away.
So in case you didn't need another reason to party on New Year.
Excellent. Well, that's what we'll be doing. We'll be popping the champagne and then checking our Twitter feed and looking for photos.
Yeah.
Although, how long does it take an image to come back from something out there in the Kuiper Belt?
So, well, we can approximate it by saying that light from the sun takes about 5.5, 6 hours to get to Pluto. So basically what we're sending back is light. So about the same. Depends where Pluto exactly is in its orbit and where the probe New Horizons is exactly.
So we might be nursing a little bit of a New Year's Day hangover by the time it gets back to us.
Yeah. They didn't say whether it's January the 1st British time or
well, that's
otherwise.
the point. Yeah.
Anyway, around about.
Yeah.
It's going to be pretty exciting.
Let's not get too hung up on it. So we have gone from, in the space of a fairly short period of time, to having an incredibly pixelated picture of this far-flung lump, which we've demoted from planet status to dwarf planet status, to now, high-resolution photographic images of a lump which has incredible surface dynamics. It's got an atmosphere, it's got wind, it's got dunes. We've come a long way with Pluto. I think it's fair to say.
Definitely, yeah. And actually, there's a really nice quote that I wrote down here from Patrick Moore, the astronomer.
Famous astronomer.
Famous. I love Patrick Moore. And this is in 1955. He wrote about Pluto, and I quote, "Plunged in everlasting dusk, silent, barren, and touched with the chill of death."
See, now that's not mucking around.
Yeah.
He's talking about
God of the underworld.
Yeah, he's talking about God of the underworld. But he's also talking about that sort of earlier image of that I had in my mind, which is that Pluto is this cold lump of rock. That there's that there's just nothing there, which is what you might expect for something so small, so far away. But that's not what we've seen.
No. And there's a really contrast this with a quote from Professor Hayes at Cornell, who now says that Pluto is, a quote, geologically diverse and dynamic, a world driven by internal heat, extreme seasons, and sublimation.
Do you know what? I think the Pluto fans have got something after all.
Yeah.
And that brings us to the end of another edition of Syzygy. If you've enjoyed the show, then as ever, it really helps us out if you tell us that. And the best way you can tell us that is by leaving a review, some stars, a couple of words, a big thumbs up on your podcast directory of choice, whether that's the Apple podcast directory on iTunes or whether it's through any of the other directories that you can find. You can also come and find us on our website, syzygy.fm, that's syzygy.fm, and there's a form there that you can contact us and send us through your comments, your queries, any questions that you send to us. We'll try to come up with a decent answer, and we might include it on a future episode, depending on whether or not we can figure it out for ourselves. You can also catch us on Twitter.
Yes, that's SYZYGY again. And
no, it's not. Syzygy Pod.
It's Syzygy Pod, so yes. I knew that.
You knew that. Yeah, because you check Twitter all the time.
I do, actually. It's the best way to get NASA stuff. Straight out of that. That's great.
Yeah, so we're at Syzygy Pod on Twitter. That's right.
And actually, I wanted to mention before we left today that the Syzygy logo, we'll put a link to the original photograph that New Horizons took. Now, this is a photograph it took after it had visited Pluto, turned around and took a picture of Pluto with the sun behind it.
Ooh.
Actually looks a little bit similar to our logo.
Okay, looking
really
forward to
nice.
that. That'll be good. We'll put that one in the show notes. And you can find all sorts of information about the things that we talk about in the show notes. And those of you who are listening to this on a special subset of all the podcast players that you can find out there, some of them you may have noticed we actually have pictures along the way as well. So if you're missing out on that side of the podcast, the enhanced image side of the podcast, maybe go and check out whether or not your podcast player can do chapter images. That's all I'll say for now. Little treat for you to find out if you haven't seen them before. The podcast is produced by me, Chris Stewart, here in the palatial studios that we have, the podcast studios here at the University of York. It's actually Emily's office, but it's nice and comfy. It's a nice place. I might put a picture of this in the show notes. We'll have a look. And where Emily is, of course, the director of Astro Campus.
Yes, here. At the University of York.
Yeah, so thank you to the University of York for giving us the time and space to do that. But speaking of time and space, we're out, so it's time for us to head off. We will catch you for the next episode of Syzygy in, I don't know, a week or so, thereabouts.
Yes. Yep. See you next time.
Yes, indeed. Bye for now.